Okay, so the last video, I ended up looking at this screen here, and it was really just looking at the different steps along the gravity correction process and what do the corrections themselves look like, and then what do they make the data look like. And I think I still didn't feel 100% happy with this, because you can see here the terrain correction, I don't know, to me looks very different from the elevation. I suppose unless you're correcting for this change here. But anyway, sorry, I've just realized that now. I'll have to process that in my head. And so I was really just trying to understand better what was going on at each step so I could feel comfortable with it. I'm actually doing this because a colleague's trying to write some gravity correction software in Python and asking me to check that it fits in with what Geosoft shows at the university. And so I was really trying to understand each step and what goes along. I mean, this is a very big challenge for geophysicists nowadays with such good software. We click buttons, but do we know what's going on at each step? So I realized, well, actually, I was going to look at the profile data because, as another colleague always told me, that's the best way to understand the data. And so let's click here. That's what I started doing here. And so there's going to be a lot of profiles on the screen by the end. But yeah, I hope it helps you understand the data better. But if nothing for myself, it helps me understand the data in 10 years' time when I have to do this again and I've forgotten. And so you can see on the screen at the moment, we have in dark purple the gravity data. This is the original Geosoft gravity data that they gave for this tutorial. Then we have in pink here the elevation. And I mean, like, they're exactly opposite. I hope I haven't chosen the wrong data. I mean, it's crazy how exactly opposite they look. And then you go and do all these corrections. I mean, I know that this plot here is very overwhelming, but I put everything in here. So you've got your tide, your drift, and your latitude corrections. That's this pink, green, and orange. So it's this pink, green, and orange. These are these straight lines on this plot, because I think it's mainly because these are divided up by day. This is all the survey data in one line. And then you go on to the terrain correction, which unfortunately is a very similar orange, but this is this a lot more detailed orange curve. And then we've got the free air correction, which is in dark blue here. And so, yeah. So those corrections are done. And so I really wanted to understand, well, which of these corrections are bigger? And so in Geosoft, I did the plot, and so you get values here. And so looking at your tide and your drift corrections, which are some of the first ones you could do, you can see they're quite small. So this is 0.06 for the drift, 0.14 for the tide. Then if you move, sorry, this one here that's cut off is your latitude correction. It jumps very big because you're looking at the whole Earth, but it's only about 1. And then you move on to your terrain correction. It's actually still quite small, 0.25. And I was looking in this area, the elevation really only changes about 60 meters, which is a lot, but it's not as big as in other areas. And then we go on here to our free air correction, and it is much bigger. So you can see it's 5 milligauss. So in this correction here, this free air is actually the largest correction of all. And then looking on to the next step here, I just plotted up Bouguer versus elevation. So please ignore this bottom one here. So the Bouguer is in blue and elevation is in purple. So I was just trying to understand, well, how well does my Bouguer correlate or anti-correlate with my elevation? And so speaking to another colleague, they said in over localized shorter wavelength areas, there should be absolutely no correlation or anti-correlation whatsoever. They shouldn't look similar, but over long wavelengths, they can be the opposite. And I think that's kind of what you're seeing here on the end. You can see one is going up while the other is going down, and vice versa. But in the shorter wavelengths in general, I don't know if you would say there is no correlation. But yeah, that helped me understand that a bit better. And then the last plot I've got here is the original gravity data in dark purple and the Bouguer data here in blue. Just to see, well, how much of a change is there actually? Because if I go back, and I know this is going to be a few slides, this over here is a plot of the original gravity, and this is a plot of the final Bouguer. And I mean, generally the same. You've got pinks on this side, a bit of blue on the side. But I mean, there's quite a bit of changes, largely correlated with topography, because you can see this pink here is linked with this blue, and this feature here is also on the elevation. So, I mean, you're removing that, you're coming out with this. So I really just wanted to understand how much the shapes look the same, but also what are their values. And so you can see in the original gravity data here, between this value here and up here, you've got about 12, assuming that this is in milligauss, which I think it was. So, and assuming my maths is right, so we've got doing about 12 here. Whereas by the end of your correction, you're down here to under 2 milligauss worth of variation within your data. But I mean, the shapes are generally the same, going up and down. I mean, there's a lot more of a difference, I'd say, in this region. But in these regions over the long wavelength, there is a lot of similarity. So yeah, this just gave me an idea of how the data was changing over time. I don't think I've got any other plots. Oh, I put these two next to each other, which I've pretty much just shown you now. This was the original, the Fourier correction based on the elevation, obviously, and then what you come out in the end. And you can see here from the scale, even though it is small, you've got about 2 milligauss variation here, whereas here you've got 12, and your Fourier is about 5. So, I mean, they are quite different grids in the end, though I think you've definitely got a regional, possibly being higher on this side and low on this side, that you might want to look at removing if it was due to deeper geology. And then, yeah, the smaller variations here are probably due to the shallower crust. So again, maybe pulling out the profiles will just help you understand your data a little bit more.